Hello viewers, welcome to Ajadi Math class. Today we shall continue with our series on statistics for beginners. So today we are going to be working on the mean and the median of grouped data. Yeah, in our last video, we've been able to talk about mean and median of ungrouped data. So today we are moving straight to the group data. Now looking at the question given to us here, we have these observations being grouped as shown here, and we have the frequency for each of it. Now, what we are expected to do is to calculate the mean, and don't forget from the definition of the mean that calculating the mean, we have that the mean is the formula for calculating the mean, we have it to be summation of x over summation f. This means that the summation of that is the plural of the frequency and the midpoint x, so which is what fx. So we are going to get the summation and divided by the summation of this frequency. Now the first thing we are going to do is to calculate the summation of our frequency, and from here we know that our summation of our frequency is addition of everything. We have 3 plus 5 plus 6 plus 7 plus 9 plus 8 and 7. This is going to give us 38. That is the summation of our frequency. Now calculating our midpoint, because the midpoint is going to stand for our score. So calculating the midpoint between 40 and 49, just on a rough sketch, if you have 40 plus 49 over 2, and that's going to give us what? 89 over 2, and that's going to give us 44.5. So the midpoint of this is going to be 44.5. Calculating the midpoint for 50 to 59 is going to give us what? 54.5. This is easy to know, just add 10 to it, since it is at equal interval. And this is going to give us 74.5. This is going to give us 84.5. And this is going to give us 94.5. So that is our midpoint. Now the next thing for us to do is to calculate our fx. That is the product of our frequency and the midpoint x. So 3 times 44.5 is going to give us, you can use your calculator for confirmation of this. This is going to give us 133.5. And 5 times 54.5 is going to give us 272.5. 6 times 64.5 is going to give us 387. 9 times 74.5 is going to give us 670.5. And 8 times 84.5 is going to give us 676. And lastly, 7 times 94.5 is going to give us 665. Okay? So, adding this together, the summation of our fx, this plus this, plus this, plus this, in total is going to give us 2,804.5. So this is our fx. So this is going to stand for our what? Summation fx. So calculating the mean here, we have that our summation fx, which is 2,804.5, divided by our summation f, which is 38. So this is going to give us 73.8. This is our mean. So this is the average for these data sets. So you can see that the method of group data is quite different from the method of ungroup data, being that here we need to calculate our midpoint because we need to know the average observation for this range of values. So this is mean. Now we are going to move straight to median of group data. And for calculating the median of group data, it has a formula, and the formula is easy to know. Yes, it is very easy to know. And for that, let me change my pen here. Yeah, let me change to red. So, for our median, we are going to make use of this formula. Let me make it thick. Yeah. So we are using this LB subscript B plus N over 2 minus cumulative frequency before the median class times the class width all over the frequency of the median class. Now, I'm going to say the meaning of all this. Here, we have that our LB okay. So here we have that our LB, L subscript B, is the lower limit of the median class. Is the lower limit of the median class. And our N is the number of observation. Okay? We have that as our number of observation. We have our CFB to be the cumulative frequency before our median class. Okay? So there is the cumulative frequency before the median class. Sorry for using abbreviation. And we have our F subscript M, which is the frequency of the median class. So it's the frequency of our median class. And lastly, we have C, which is the class width, or let me say class size. Yeah, let's call this class size. Yeah, looking at this, from here we know that our lower limit, the first thing for us to determine is to determine our median class. And for you to determine your median class, in our last video you can check, we talk about how to determine median, okay, of group data. Now the summation F we have here is 38. So when you divide 38 over 2, it's going to give us 19, right? So let's calculate our cumulative frequency, and let's see first. So our cumulative frequency means addition of the subsequent frequencies. And here we have 3, starting with 3. And next we have 3 plus 5, right? We have 3 plus the next value, which is 5. So that's going to give us what? Let me put it this way, that we have 3 plus 5, which is going to give us 8. And next one, we have the previous value, which is 8 plus 6, right? Sorry. And which is going to give us 14. So subsequently, like that, 14 plus 9 is going to give us 23. 23 plus the next value, which is 8. Okay? Next frequency value, which is going to give us 31. And to the last value, which is 7, is going to give us 38. So this is going to give us 38. Now let's check. Since our summation F our summation F is 38. Okay, so our median class is going to be over 2, which is 19th value. So where does our 19th value fall? So we can see that it falls on this region. Yes, it falls on this region. So this is going to be our what? Our median class. Let me change the pen so we can see what we mean by the median class. So our median class is going to be this. Oh, so which is this? Straight down like this. So it's 70 to 79. So looking at this now, what is going to be our lower limit? So our lower limit is 70, while upper limit is 79. So our lower limit is 70, right? And our number of observation from 40 to 49. Students often make mistake here whereby saying that 40 to 49 is 9. No. So 40 to 49 is 10. We have 10 digits. Okay, when you count from 40 to 49. So here we can say that our n is 10. And the cumulative frequency before the median class. Since this is our median class, so the cumulative frequency before it is what? 14. Okay? That is our cumulative frequency before it. We have it to be what? 14. And lastly, we have our frequency. Our frequency of the median class. So the frequency, since there is a median class, the frequency of the median class is 9. Okay? So the frequency of the median class is 9. While our class size is 10. Oh, sorry. Our number of observation can be 10. That is a mistake from my part. It's 38. Okay, our number of observation is the same thing as summation F. Okay, now doing this, we are going to make use of these values in computing our median. So coming down here, we have that our median will now be equal our lower limit, which is 70. We can decide to use boundary if you like, instead of using limit. Okay? In bracket, n over 2, our n, which is the number of observation, which is 38 over 2, minus the cumulative frequency before the median class, which is 14, all over, okay, we have this closed, times our class limit, which is 10, everything over frequency of the median class, which is found to be 9. So going forward, we have 70 plus 38 divided by 2 is going to give us 19 minus 14, everything over 9 multiplied by 10. So here we have 70 plus 19 minus 14 is going to give us 5 over 9 multiplied by 10. So we have 70. You have 70 plus 5 over 9, or 5, let's multiply 5 by 10, and here we are going to have 50 over 9. Okay, so going forward, we have 50 over 9. You can solve that using your calculator. So we are going to have 70 plus 50 over 9, because I am doing this without using calculator. We know that 50 over 10 is 5, right? So let's do that somewhere here. We have 50 over 9. 9 in 50, 9 times 5 is 45, right? So you have that as 5. Remainder 5. So you can have that as 5.5. Okay? So cos 9 50 is 45, remainder 5, add 0 to it, 50, so you can have 5.5. So here you have 5.5. And finally, our answer is going to be 75.5. So this is our final answer. One thing you will observe with the median is that the value you are going to get here as the median value must fall within this range from 70 to 75. If it falls outside this range, it shows that what? It shows that your answer is wrong. So you can see that the median class is somehow greater than the midpoint, which is 74.5. So kindly subscribe to our YouTube channel so that you can be notified of our subsequent videos on this series, and we hope to upload more videos. In our next video, we'll be uploading videos on how to do mode of group data and also of ungrouped data, and also try to help us share and like this video, comment. Thank you very much. See you next week. Hello viewers, welcome to Ajadi Math class. Today we shall continue with our statistics for beginners. This is our 4th episode on this series. Today we are going to start with the mode of group data. And in our previous videos, we've been able to look at the mode for the mean. We are able to look at the mean and the median of group data. So today we shall move straight to the mode of group data. And the formula for our mode of group data, we have that mode equals to the lower boundary, okay, LB plus F1 over F1 plus F2 multiplied by C. So we can possibly easily put this in a bracket for easy computation. So where our F1 is the same thing as the frequency of the median modal class minus the frequency before it. So looking at this now, this is our frequency of the modal minus the frequency before, and also our F2 is the same thing as the frequency of the modal class minus the frequency after it. And here our C is the class width. That is, you can call it the class interval also. That means the difference between the lower and the upper. And LB is the lower boundary. So these are the parameters that we have. Now we are going to use this to compute the information given to us there. Now for us to do this, now we are making use of the same formula here. We have that our mode equals LB subscript B plus F1 over F1 plus F2 multiplied by C. So with this, our lower boundary, the first thing we are going to look at is to determine our modal class. And our modal class is where you see the highest frequency, and this is our highest frequency. So this is where our modal class is, which is 25. The highest frequency is 25. So this is our modal class, that is 6 to 10 and 25. So this is what we are going to put into consideration. And for us to determine our lower boundary, we know that our lower limit here is 6. Okay, so you are going to subtract 0.5 from this lower limit 6. So our lower boundary is going to give us 5.5. In my previous video for the median, I decided to use the lower limit directly because you can also do that. But in this case, I'm going to use the lower boundary by subtracting 0.5 from the lower limit plus F1. Our F1, don't forget, is the frequency of the modal class minus the frequency before it. And the frequency of our modal class here is 25. So let me put that in bracket for easy computation. Minus the frequency before it, which is what? 20. That is my F1. Everything over F2, which is the frequency of the modal minus the frequency after it. And the frequency of the modal class is 25. The frequency after it is 23. That is my F2. My F1, I'm going to repeat this, which is 25 minus 20. multiply by my class width, which is 5, from 1 to 5, so which is 5. Now simplifying this further, I'm going to have 5.5 plus 25 minus 20 is going to give me 5 over 25 minus 23 is going to give me 2 plus 5 multiplied by 5. And with this, I'm going to have, and my mode is going to be 5.5 plus 5 over 7 multiplied by 5. So with this, I'm going to have 5.5 plus, 5 times 5 is going to be 25. 25 over 7 is going to give me 3.57. We can add that together. So the mode is going to be 9.07, and approximately my mode is going to be 9. So that will be the height of the student. If the height of the student is in meter, or any unit the height of the student is, so we're going to have the same thing here. So this is what I just have. Okay, now looking at this now, you are going to see that this value 9 must fall within this range of 6 to 10, just like the same thing we did in the median. If it falls outside it, then there's a mistake somewhere. So this is our frequency, the frequency for the modal class. And our final answer here is 9. Thank you very much, and please don't forget to subscribe to my channel. In our next video, we are going to move straight, because we are done with the measure of central tendency. We are moving straight to measure of dispersion. So when Hello viewers, welcome to Ajadi Math class. Today we shall continue with our episode on statistics for beginners. Before we proceed, kindly subscribe to my YouTube channel. So in our previous videos, we've been able to look at measure of central tendency, and today we shall proceed with measure of dispersion. And the first thing we are going to define here is the range. From the definition of range is the difference between the highest and the smallest numbers in a given set of numbers. Now, looking at the first example we have here, we have the find the range of this set of numbers. So from the definition of range, we know that range is the same thing as the highest number minus the smallest number. And from this observation, we can see that our highest is 20, while our smallest is what? 3. So this is going to be 20 minus 3, which is 17. So you can see that calculating range is very easy, even for group data. Just look at the observation given to you, the highest value minus the lowest value. That is the value of range. And secondly, we are going to look at the mean deviation. The mean deviation. So we are going to consider 2 cases for this mean deviation. And the first case is when you don't have the frequency. So here we are going to have summation x minus x bar over n. Take note, this is an absolute value. When you say an absolute value of x, it can assume 2 values, either the positive, that means the value of x can be positive or negative. So the absolute value only take into consideration the positive value. So that is the purpose of the x, absolute value for the x. Now let's consider a situation whereby we have a new data set. We are going to consider the mean deviation for this same data set, 3, 4, 8, 9, 16, and 20. So our observation is 3, 4, as we have up there, 8, 9, 16, and 20. So we have to consider calculate the mean deviation. The first thing for us to do is to calculate the mean. And in our previous video, we've been able to talk about that. Don't forget that the formula for calculating mean, which is x bar, is the same thing as the summation of x over n. That means all this observation must be added together. So we are going to have 3 plus 4 plus 8 plus 9 plus 16 plus 20. everything over how many observations? 1, 2, 3, 4, 5, 6. We have 6 altogether. So calculating the mean of this, so we have our mean, which is the same thing as x bar, to be equals to 3 plus 4, 7 plus this, we have 15, plus 25, which is 40, plus this, which is 60 over 6. So our x bar is 10 in that regard. So using this same definition formula to be summation x minus x bar over n, so my mean deviation, I can represent that with md, is going to be summation of my x minus x bar. That is the positive value, okay, of my x minus x bar. So my x now is 3 minus 10, okay, the positive value of it. The next observation, which is 4 minus 10, plus the next observation, which is 8 minus 10, plus the next observation, which is 9 minus 10, plus the next observation, 16 minus 10, and the last one, which is 20 minus 10. So we are taking the absolute value of the observation. This is going to be over n. How many observations do we have in total? Which is 6. So calculating this now, using the value given to us there, 3 minus 10 is going to be negative 7. Taking the absolute value of that is going to be positive 7. 4 minus 10, you are going to have 6 plus 2. Don't forget, you are taking only the positive value because of the presence of the absolute value, plus 1 plus 6 plus 10, all over 6. And this is going to give us 7 plus this is 13, 15, 16, 22, 32. So here we are going to have 32 over 6. And that should give us 5.3 something. So that should be our what? The mean deviation. And what's the purpose of mean deviation? This is to see how our observation is far from the average. That is the purpose of mean deviation. Hello viewers, welcome to Ajade Math class. Today we shall continue with our series on statistics for beginners. So today we are going to work on the variance and standard deviation for the ungrouped data. So in our previous video, we've been able to work on the mean deviation for the ungrouped data. So today we shall continue with the variance and the standard deviation. Like I told you, if we're talking about the variance and the standard deviation, this is just looking at the square difference of members from the mean of the data, the deviation from the mean of the data. So today, I'm going to give you the formula for the variance. So the first formula, if it is the population variance, we can use sigma square. Okay? We use this to represent what a variance is. So it's going to be summation x minus x bar, almost the same thing with the mean deviation we did in the last class, squared over n. So the n is the number of what? Observation. Okay? And in this case, alternatively, you can use another method for this, but for the sample variance in which we are going to work on today, we can have s squared to be equals to summation x minus x bar all squared all over n minus 1. So the only difference between these two is that here our n decreases by 1. So that's what we are going to work on today. So for this, we can have this in this form, or alternatively, it can be written as summation x squared over n minus x bar all square. Don't forget our s bar is the mean. So we are going to use these two formulas to solve our example given here. So here we are told that given the following data set 35787, find the variance and also the standard deviation. Yeah, before I proceed, don't forget also that when we talk about the word standard deviation our standard deviation, I'm going to use STD to represent that, is the same thing as the square root of variance. So whatsoever you get for your variance, just find the square root. So that is equivalent to our standard deviation. Now, for us to do this now, the first thing we are going to do, since we are calculating the variance, so our variance is going to be, let me use S square, it's going to be, let's use the first formula, x minus x bar all squared over n minus 1. So we need to calculate our S bar first. So calculating our S bar, which is the mean. In our previous video, we've shown how to calculate our mean. So that means addition of everything over the number of observation. And that's going to be 3 plus 5 plus 7 plus 8 plus 7. So we're dividing everything by number of observation, which is 5. So this is going to give us 30 over 5. And our mean is going to be 6. So now making use of the formula here, which is summation of x minus s bar. So our variance will now be equals to our x, that means each of the observation minus the mean. So here we are going to have the first observation, which is 3 minus 6 all squared, plus the next observation, which is 5 minus 6 all squared, plus the third observation, 7 minus 6 all squared, plus the fourth one, 8 minus 6 all squared, plus the last one, which is 7 minus 6 all squared. Okay, we are dividing everything by our n, which is what? Which is 5. So let's use of the population variance. So I'm going back to this. So that means instead of using n minus 1, I'm going to use this in this case, because here we assume that we are working with population, not the sample in this case, because the question does not indicate whether it is sample. So we regard our information given as the population, So solving this now, here we are going to have 3 minus 6 all squared is going to give me 9 plus 1 plus 1 plus 4 plus 1 all over 5. And this is going to give me 16 over 5, which is equivalent to 3.2. Mind you, don't forget that from here, our standard deviation, that's it for our variance, right? So here, calculating our standard deviation is the same thing as saying the square root of our variance. And don't forget our variance here is 3.2. So this is the same thing as saying square root of 3.2. So our standard deviation in this case is going to be 1.79. So this is for the first method. This is for the first method. Using the second method, which has been given to us here to calculate. So we are going to make use of this second formula to calculate our variance. So here we have our variance to be equals to summation x squared over n minus x bar squared. So we want to check if we are going to get the same answer for this. So here we need to know our summation x squared first. And since the summation x squared equals, that means each of the observation square, each of the observation, that is 3, 5, 7, 8, 7, we are squaring each of it, is going to be 3 squared plus 5 squared plus 7 squared plus 8 squared plus 7 squared. So this is summation of our x squared. And that is going to give me 196. Okay? And don't forget our s bar square. So in this case now, our variance, my variance here is going to be summation x squared, which is 196 over 5, which is the number of observation, minus x bar all square. And my x bar, in this case, from here, my x bar is 6. So minus 6 squared. So this is going to be 196 over 5 minus 36. So solving this further, I'm going to get 3.2. So calculating the standard deviation also is still going to be square root of 3.2, which is going to be what? 1.79. So this is for the standard deviation and also for the variance of what? Of ungroup data. Before I leave, I have to tell you this. This can be extended to when you have frequency of number. So that is, our variance, when frequency is involved, can be equals to summation f, okay, into bracket x minus x bar all squared all over summation f. So that's the only difference. Instead of using n here, we are going to use f and f here too. So those are the two formula that we have in this case. Okay, so you can use this to solve this as a classwork and put the answer in the comment section, such that when you have x and we have f, we have 0, 1, 2, 3, 4. And we have the frequency to be 3, 2, 4, 1, 2. So I want you to use this to calculate the variance and also the standard deviation. Don't forget that the standard deviation is just going to be the square root of our variance, which is summation f into bracket x minus s bar all squared over sum. My class. Today we shall be working on episode 7 of our statistics for beginners. So today we are asked to calculate the mean, the variance, and the standard deviation for the grouped data. So the first thing we need to do is to get the middle value. And for us to get the middle value, since our class interval is 50 to 59, then we can say that our mid value will be equals to the average of the two. That is, we are going to say we have 50 plus 59 over 2. And 50 plus 59 is going to give us 109 over 2, which is the same thing as saying 54.5. So our mid value here is going to be 54.5. If the same thing is done to 60 to 69, so here we are going to have 64.5. And here we are going to have 74.5. Here, the middle value is going to be 84.5. And lastly, don't forget, here, the interval is from 90 to 100. So our mid value is not going to be 94.5, but instead, the average is going to be 95. So that is our mid value. Okay? And looking at our frequency, don't forget that for us to calculate the mean for the group data, we have that our formula for calculating the mean is summation fx over summation f. So we need to know the summation of our frequency, that is 3 plus 5 plus 9 plus 12 plus 8, and that is going to give us 37. Okay, so now we need our fx, that means frequency multiplied by x. So using your calculator, 3 times 54.5 is going to give us 163.5. And 5 multiplied by 64.5, here we're going to have 322.5. Here I'm going to have 670.5. Here I'm going to have 1014. And here lastly I'm going to have 760. So calculating the sum of everything, that is adding everything together, the sum is going to be 2,930.5. So with this, my mean is going to be 2,930, which is the summation of fx over summation f, which is 37. And from this, my mean is going to be 79.2. So looking at my formula here, there's a need for me to put S bar. So don't forget that the mean is the same thing as saying X bar. That is from our previous video. I've explained the notation used for mean, so we can use S bar. So what we just need to do here is to get x minus x bar and square it. What do I mean in getting this? For the first value, it means x. My x is 54.5. That is, I have 54.5 minus x bar, which is 79.2. So I'm going to subtract this and square. You understand? So the same thing will be done for the second one, that is 64.5 minus 79.2, then squared it. So using your calculator, 54.5 minus 79.5 squared is going to give me 610.09. And for the second one, I'm going to have 216.09. I'm going to have 22.09. Here, I'm going to have 28.09. Here, I'm going to have 249.64. Okay, so lastly, we are going to do F. And the reason why I'm doing this, from the formula of calculating my variance, from our previous video, I gave you the formula for variance, which is summation F into bracket x minus s bar all squared over n minus 1, or you can say summation f minus 1, either way, or you can use n minus 1. So here there's a need for me to get f multiplied by x minus s bar all squared. So here the first value here, using now my frequency multiplying it with this, so I'm going to have 1,830.27. Here I'm going to have 1,080.45. I'm going to have 198.81. Here 337.08. 1,997.12, and the summation of everything is going to give me 5,443.73. You can use your calculator for that. So calculating my variance in this sense, it shows that the summation of f into bracket x minus s bar all squared gives me 5,443.73 all over summation f, which is the same thing as 37 minus 1. Okay, and with this shows I'm going to have over 36, right? So dividing this gives me 151.2. And lastly, we are to get variance and the standard deviation. So our standard deviation, from the last video, we know that our standard deviation, SD, is the same thing as square root of our variance, which is the same thing as square root of 151.2, and my standard deviation is going to be 12.3. So that is it for the grouped data. So kindly subscribe to my YouTube channel. In our next video, we are moving to more important topic in statistics. Until then. Hello viewers, welcome to another class. Today, we want to estimate regression parameters. So, we have this general regression form. Don't forget that this is a multivariate form. And here we have that our y equals to xb plus what? Plus epsilon plus e, which stands for the error term. And this is the parameter we want to estimate. So before we proceed, don't forget that our e is normally distributed with mean 0 and variance sigma square. So we can also estimate that. But this is our area of concentration. So we have this. Rewriting this given equation, we can rewrite our E to be equals to y minus xb. That is, we're looking at the deviation of the observation, okay, from the mean. So that is the, what's it called, the error. So with this, our epsilon prime epsilon is the same thing as having y minus x beta prime, which stands for the epsilon prime of transpose. Either way, let me call it the transpose. Y minus this. Okay? So, let this be what? Be Q. So, by so doing, we can have, we want to distribute. So, we can have the Q to be y prime multiplied by y. Don't forget, this is a matrix multiplication. So we need to be very cautious. We're going to have y prime y. Y prime multiplied by xb, we're going to have negative y prime xb. X beta multiplied by y, we're going to have beta prime x prime y. Now, I need to explain something here. Looking at this is a transpose value. So I'm using prime in the case of transpose. So I didn't say S prime, B prime. No, it's going to be what in reverse order. So that is when you have A, B, C transpose. So if you want to bring this out, it's going to be C prime, B prime, A prime. That's the rule. Okay, so the same thing is being used here. So the last one is to multiply this by this. So here we're going to have plus B prime, X prime, XB. So there's another thing we need to take note of, and that is the issue of transpose. Looking at these two, we're going to see that y prime x beta, if this is being transposed, it's going to be the same thing as beta prime x prime y. That shows that the transpose of this is the same thing as this. So we're going to be the same. They're going to be the same. So here we have q to be equals to y prime y minus 2 beta prime x prime y plus beta prime x beta. The multiplication is possible because we take cognizance of the order, the dimension of this. So if the dimension contradicts, then the multiplication cannot be done. From this equation, we're going to differentiate with respect to the parameter we want to estimate, which is the beta. So here, I'm having my dq, the beta. I'm going to differentiate this q with respect to beta and equate the answer to 0. So with this, I'm going to have differentiating this with respect to beta. No, there's no beta, no parameter here. It's going to be 0. Differentiating this with respect to beta. So here I'm going to have negative 2x prime y. Differentiating this with respect to beta, this is like having beta squared. So differentiating, so it's like you having beta prime x prime y. It's like this is being squared. So this is going to come to the back. So we have 2x prime x beta equals to 0. This has been estimated. So with this, we can have 2x prime x beta equals to 2x prime y. Dividing both sides by 2. Okay? So don't forget, this is a matrix multiplication. So we want to get rid of the coefficient of the beta, which is s prime x. So this is going to be beta cap equal x prime x inverse is a matrix x prime y. So this is the general form of our parameter beta. Now we want to estimate. And part of what we're going to do here is that we've known the value of beta to be this. So how do we get our expectation of beta and also the variance of beta? We have beta cap to be equals to x prime x inverse x prime y. So here we want to find the expectation of our beta cap. And our objective is that to show that it is an unbiased estimate. And don't forget that we have y equals to x beta plus e. And expectation of y is going to be x beta plus the expectation of epsilon. And recall that our epsilon follows a normal distribution between 0 and variance sigma squared. That shows that expectation of epsilon is going to be 0, so our expectation of y is going to be x beta. So here I'm having the expectation of x beta cap, so which is the same thing as saying x prime x inverse x prime the expectation of y. Now, because these are predictors variables, right? The x are the predictor variables. Okay. So here we have x prime x inverse x prime. Expectation of y is the same thing as x beta, which is the same thing as x beta. Now, looking at these two matrices, s prime x inverse multiplied by x prime x. So this shows that this is just going to be what? It's going to be 1. So here we can have our beta. So it shows that it's an unbiased estimate. Secondly, we need to estimate the variance of beta also. We have the variance of beta cap to be the variance of the beta cap, which is the same thing as this. We're going to plug in the value of this x prime x inverse s prime y. Here, I'm going to take you through a quick review of something. Don't forget that if you have variance of ax, whereby a is a constant, the rule is that we're going to have what? A squared variance of x. The constant is going to be squared. And if it is in matrix form, if you want to leave it in matrix form, it's the same thing as a variance of x a prime. So I'm going to use this second approach. Okay. So this is going to be my constant. This is going to be my a. X prime x inverse x prime is going to be my a in this regard. So using the same approach, I'm going to have my a coming out, which is s prime x inverse x prime. So the variance of my y, variable y, and then the transpose of this, a transpose. So I'm going to take the transpose of this, and taking the transpose from the previous explanation I did is going to be in reverse order. So this is going to be x prime x inverse in reverse order. So it's going to come like this. And the transpose of s prime is going to be x. So we have x prime x inverse. Don't forget that the variance of y is the same thing as sigma squared. So I can have this as sigma squared. That is the variance of y is the same thing as sigma squared. So here I have my x prime x inverse x prime. Then I'm having my x here. And here I'm having my x prime x inverse. So this goes. So therefore, I can say that the variance of my beta cap is going to be sigma squared x prime x inverse. So that's the second thing I'm going to do. And lastly, is looking at the point estimate of our parameter beta. I'm going to clean this. So doing that, I'm going to have, for the point estimate, the rule is that you have the parameter you want to take. For instance, we have b naught plus b1 x1. This is the general form of a linear regression. Okay, so for instance, you are interested in estimating b1. The general form is very easy, which is your b1 minus the expectation of your b1 over what? The standard error of your what? Of your b1. That is just the general form. The parameter itself minus what? Minus the mean of the parameter over the what? The standard. Deviation, standard error of the parameter. Standard error of the parameter. So that is just the general form for what? The point estimate. So here I'm going to stop. In my next video, I'm going to proceed by looking at some other factors and properties of what? Of regression. Thank you very much for watching my videos. Please can you subscribe to my YouTube channel. See you next time. Thank you. Hello viewers, welcome to my class. Today we are going to work on the analysis of variance known as the ANOVA. So I'm going to put you through the basic model of the analysis of variance and also on the decomposition of the sum of squares. So generally we should know that the model for the analysis of variance is Yij equals mu I plus Eij. And one of the basic reasons for studying this analysis of variance is for us to look, the application of ANOVA is majorly used in any design of experiment, be it in the agriculture or in any other field. So we are going to look at the treatment effects. How does the treatment perform? Is there any difference in the treatment, or there's no difference? So these are the things in which we are going to look at. But there's a need for us to know the statistical background regarding this. So here we have our Yij. This talks about what? The observation. Okay? And we have our mu I. So the mu I is the same thing as the what? As the treatment mean. So this is the mean of the treatment being assigned. And we have our Eij, which is also known as what? The random error. So mu I, this model can also be written as our Yij equals mu plus tau I plus EIJ, where our mean I, which is the treatment mean, can be split as the what? The overall mean, and also what? As the treatment effects. So our mean is known as the what? Overall mean, and our I is known as the what? The treatment effect, where our EIJ is still the same thing as our what? Random error. Because statistically speaking, for every experiment, we should give room for what? Error. Because no experiment is perfectly carried out. So there is possibility of you having an error. So we need to estimate the error also. So now with this is going to give us a guide on how to decompose our sum of squares, in which all these general formula we know about Hanover. How do we get this formula? This is what we want to work on. So this is going to take, looking at this, if you estimate this population mean, which is known as the overall mean, okay, which is also known as what? Our y dot bar. Okay, the estimate of it. So don't forget that we have our observation equals this. So this is what I'm going to use to estimate my what? My sum of squares. So now, under the decomposition of the sum of squares, I have that my SS total. When I use the word SS, this means what? Sum of squares. So that's the meaning of SS. So for the total, that means for the general treatment, so we have our SS total to be double summation, where my I sum from what? 1 to what? A, and my J sum from 1 to N, Yij, okay, which is the individual observation, minus the what? Minus the overall mean square. And if you look at this, don't forget that our I sum from 1 to what? A, and J sum from 1 to N. So when we get to the two-way Hanover, which is known as the RCBD, which is a randomized, completely block design, then we can talk about the blocking effect and also about the treatment effect. But in this case, we are not considering the blocking. Okay, we are only limiting it to the what? To the treatment effect. Now, we want to decompose this. Okay? So what we want to work on is the decomposition of our what? Of our SS total. So how do we decompose our SS total? So that's what we want to work on. So we have our SS total to be double summation. In this one, I'm going to omit the use of the notation, that is I to A, J to N. Okay? But when I need it, I'm going to make use of it. So I have Yij minus y bar dot squared. So decomposing this is the same thing as saying my double summation Yij introducing minus yi dot bar plus yi dot bar minus y dot bar all squared. Don't forget, this is what we have initially. So my yi dot bar, this is known as what? Treatment mean. This is the same thing as the treatment mean. Okay? So minus yi dot bar plus yi dot bar, it can cancel out, which shows that this is still the same thing as this. Just that for me to get my decomposition well, I need to introduce the treatment mean. Okay? So using this, if you want to distribute this, that means factorizing this, or let me say expanding this. Okay? This is the same thing as saying yij minus, just take these two, okay, call this two a, this b, it's like you having a plus b. And don't forget, if you want to factorize a plus b to the power of 2, you are going to have what? A squared plus b squared plus 2ab. Right? So the same thing is what I'm going to use there. So you are going to have a squared plus b squared plus 2ab. So that's what I'm going to use here. So my a, which is yij minus yi dot bar squared plus double sum yi dot minus y dot bar squared plus 2 double sum, which is AB. Now we have yij minus yi dot bar minus y dot bar. This is